Okay, so in this problem, we have a truss with a load of 100 kips applied at C, a pin connector at E, and a roller at D. So we got, again, 3 unknowns, reactions, and if you count them up, 7 bars, 7 unknowns. Now it's a good thing to always start a problem looking for zero force members. Do you see any potential, what we call case 1 elements? A. What's good about A? Well, it's got 2 elements, right? But more importantly, no load. So that means right off the bat, I can write that I have a couple of zero force members. And to connect that back to what we've done in class, I'll call that case 1. That was the 2 elements concurrent at a point with no load. So that means that I know that the force in AB is equal to the force in AE and is equal to 0. Only one word of caution. If it's not a zero force member and you think it is, well, you really stepped off in the wrong direction. But if not, it can really be a help. So very quickly, I know 2 of my elements without much trouble. With that said, I haven't found any of my reactions yet. Do I need to do that, or can I actually solve for some things before I get my reactions? Could I go to joint B now? No. I still got 1, 2, 3 unknowns. Could I go to joint C? Yes, I could. Without even finding my reactions. Could I go to joint E? Maybe. But right now, no, because I got 2 bar forces and 2 reactions. Can I go to D? No. 4 things I don't know. 3 bars, 1 reaction. So it might be a good place, again, as a good first step, get your reactions before you get started. I'm going to need them down the line. So let's do that. So I'm going to start off by assuming that I have a reaction at D, up, a reaction at E, also vertical, and I'm going to assume that I have a reaction in the X direction. Who did I leave off on? Mr. Montgomery, what should we do?
Sum the moments at E.
Sum the moments at E. I like that. Why should we sum the moments at E? Did you say D?
Yeah.
We can do it at D. You want to do it at D?
Yeah.
Okay.
I already written.
Sorry. Oh, you've already written it down. I know how that goes when you make a mistake. And are you using pen or pencil?
Pencil.
Oh, you can erase.
Yeah.
We'll do D. Now, why is D a good spot? Well, luckily, EX passes through D. It won't create any moments. So we'll be able to solve for EY. So, Mr. Thusius, do that for me.
You got a negative force up at C with a moment arm of 30 feet and the force of 100 kips.
100 kips and moment arm of 30 feet. Okay.
And then you have a negative EY.
EY.
With a moment arm of 20 feet.
20 feet. Is that it? I think so. Yep. So what's EY? 150?
Kips. Yeah.
150 kips?
Yep.
And got the right direction, so it's up. Mr. Reddick, what do we do next?
We do some forces in Y.
Yep, we can sum the forces in the Y. Would summing the forces in the X direction be a bad start? Bad second equation? No, that'll work too. So sum the forces in the Y, Mr. Mokhtar.
Well, I got positive dy.
What else?
Is dy not negative?
What?
EY is negative. EY is
Oh, we're good.
Oh, you guys are going back on me. You're right. EY is negative. Sorry about that. But on this free body, how did I draw it? EY is up and DY is up. Are there any other Y forces? Not that I see. So it looks like that DY is equal to negative EY, which is equal to 150. Okay? Miss East, you're the last one on this one. What do we do next? What is the sum of the forces in the x direction? Yeah, we just have EX, right? Nope. We have EX and, this is a tricky one, our 100. So EX is minus 100. Now remember, these minuses for the reactions just mean they're opposite of this. So we don't really have a sign convention on reaction. You choose whatever you like. So far, so good? So now what do we do? Can we go to E? Yes. Can we go to B? No. Can we go to C? Yes. Can we go to D? No. So it's going to be E or C. Which one do you want to do? Let's try that again. Everyone raise your right hand if you want to go to C. Overwhelming, not a majority. Yes. Mr. Montgomery, what did you write down?
E.
E. Okay, we'll do E there. Always defer to the little table. So here's joint E. Now, what did I get EY to be? Negative 150, which means is it up or down? Down. So I'm going to come over here and say, look, there's the actual load there. What about EX? Positive or negative? It's negative, so that means it's actually to the left. And it has a value of 100 kips. I am now going to assume a direction for the force in DE and the force in BE. Oh, that's a sweet one. There is almost no simpler free body diagram for a joint than this. No angles. Everybody's up or down, left or right. So we're back to the front. Mr. McBride, which one do you want to do? Since it's so challenging, why don't you do that for us? What is the sum of the forces in the x direction?
Minus 100 kips.
Minus 100?
Plus force.
Wow. So what is the force DE equal to? 100. Not so bad. Mr. Street, what's left? So let's sum the forces in the y direction. What do you get?
Negative 150 positive FB.
Right. So 150 down, positive BE up. So what's the force BE?
Positive.
So we now have these two guys, right? Yes, sir.
So if your EX originally was 100 kips positive and you then draw your joint E, would you draw your reaction to the right then? Or EX?
If you transfer these assumptions down to here, then what are you going to plug in for EX? Minus 100.
If that was positive 100 kips
Oh, I would have drawn it to the right.
You would have, okay.
What I usually do is once I make an assumption on a free body diagram, I don't change those. But later when I draw another free body diagram, if it helps me be more clear, I make the correction on that one. You don't have to do that. If that's confusing you, just stick with whatever you got. In both these cases, you would have plugged in negative values for EY and a negative value for EX. And you would have effectively gotten the same result. Where should we go next? Can we go to B?
Yes.
Yes. Do we want to? No. The geometry there is just a mess. So we can go to C.
Not really.
Can we go to D? Yeah. Mr. Montgomery, which one did you write down?
I did B because there are 3, 4, 5 triangles.
Oh, erase that. We're going to go to C.
Already done with that.
Another reason I want to go to B is because I have to incorporate other answers. Now, I know I'm pretty sure this one's 0. I'm pretty sure about that one, but I just don't want to deal with that geometry. This is going to be so much easier to deal with. And it's not going to bring anybody else into play. Right? No previous answers. So I think it's cleaner. Plus, I just want to disagree with you once. Okay, so I've got the applied load of 100 kips, and I'm going to assume tension in CD and tension in, I think I called, BC. So we're going to now have to start dealing with this slope. So it looks like this element drops 15 and goes 20, which is a 3, 4, 5 triangle. You guys see that? So I should be able to find my X and Y components really easily. So who did I stop with? Mr. Street, you're up, Mr. Brown. What do you want to do?
Some of the forces in the Y.
You sure about that?
X.
Why wouldn't we want to do some forces in Y? Well, both of our unknowns have Y components, but only one, BC, has a X component. So let's do that first. So let's sum in the X direction. Make sure we're in equilibrium.
So negative BC.
Yeah, what component of that?
4/5.
Right, so 4/5 of the force in BC to the left, and then what else?
Plus 100.
Plus 100. So it looks like BC is 125. You guys get that? Yes?
Yes.
It looks like it's positive. I'm sorry, Arga, what's next?
Some of the forces in the Y direction.
Yeah? So what's that?
Negative FCD.
Right?
And then negative 3/5.
Right, so 3/5 of BC. Anything else? That's it. So we want to find FCD. It looks like it's minus 3/5 of FBC. And FBC is 125. What's 3/5 of that?
Negative 75.
Negative 75? So we got this one and this one. So who's left? Little lonely BD. Should we go to B? No. Well, we can. It's still going to be a mess. I think now D looks like the best place to go. You buy that? So I'll go to joint D. So there's my force. What was the reaction at dy? Oh, let me flip back. So DOI I assumed was up, and I got 150, so I'm going to draw that, 150. I've got the force in ED. I've got the force in CD, and I've got the one guy that I don't know. The force in BD. And looks like the slope is similar to the one we did before. You got a change in the x direction of 20 and a rise of 15. So that's 3 vertical, 4 horizontal for my 3, 4, 5. And just to emphasize, this is the one I want to find.
If force CD is negative, how can you have it in tension?
Remember, I always assume everything is tension. Now, when I use CD, what value am I going to plug in? Well, I'll look back at my previous equations, and I'll plug in negative 75. So, do I want to sum forces in the x or the y direction to find BD? X. Yeah, I think x is just slightly less work, right? Because I only have to include ED, CD is out, and the 150 is out. So it should be an easier equation. Can you do it in y? Yes. So let's sum the forces in the x direction set equal to 0. Who's up? Mr. Robinson, you're up.
Negative FD and minus FBD times 4/5.
Sounds good to me. So if I solve for the thing I'm looking for, FBD, it looks like it's going to be negative 5 over 4 of FDE, right? And what was FDE? 100 positive. So I put 100 positive in there, and I get negative 1.25, right? I mean 125. Is that right? So I think that's it. So we found 10 unknowns using our 10 equations. We got off to a good start because 2 were 0. A couple of our equations were pretty easy to solve. And if you look at the timer on this video, we've just hit 17 minutes. So almost half the time of the previous problem. Is this a workable problem for the homework, for the exam? No. Still too much to do. But we're moving in that direction. Any questions? All right.